All right, welcome to your favorite intermediate algebra class. Good to see you today. We're going to talk about functions and their graphs today, and more specifically, our objectives are going to be to represent some relations and functions, and to graph and evaluate some linear functions, including a little bit of function notation. Okay, so let's talk about relations for a minute. You can have a relation with anything. It's just a pairing of input values with output values. So there's an example of some relations. That set of ordered pair or those ordered pairs right there. -1 to 1, -1's your input, to 3 your output, 1 out to 2, and so on. The domain, by definition, is just your set of input values for a relation. And you guys always probably are common with calling that x and y, right? Your input set of input values for a relation, or your set of x values, right? In this case, would be your domain. The set of output values is your set of y values. Okay, the independent variable is your input variable in an equation. So your x variable, typically speaking, right? Your dependent variable. Your output variable is your dependent variable. Your dependent variable depends on what you put in your input or your independent. Okay, so your dependent's your y. And then function, we'll get to function, but not every relation is a function, but every function is a relation. And what you want to remember is for every x, there's one y. In other words, for every input, there's one output. Okay, so for every x, there's one y. And we have this graphical test, this vertical line test, which we'll talk about as well. Okay, let's take a look here. For the following relation, identify the domain and range. You notice this is x and y, right? X and y and so on. So for part A, your domain, your set of x values is just -1. Of course, you got another -1, 1, and 2. Okay. Your range is your y values. Your range, those y values. So 1, 3, 2, -2. 1, 3, 2, -2. And you usually try and write those in order. So -2, 1, 2, and 3. Okay, there's your range there. Erase this part of it. Okay. Part B, let's map this function. Okay, so let's do a mapping here. Let's let x, so those will be our inputs, y's our outputs. And it looks like we have this mapping from -1, the ordered pair goes to 1. Okay, and then -1 also goes to 3. Okay, that second ordered pair there. And then you see the 1, 2. 1 goes to 2, is mapped to 2, and 2 is mapped to -2. Okay, so we just did a little mapping here, and you can see that this is our domain right there, isn't it? And our range right there, 1, 3, 2, -2. Okay, now let's identify whether this relation is a function. So what you want to remember, to be a function, okay, for every x, for every input, there is one y. There is one y. For every input, there is one output. Okay, so let's test this. So what I do is I put my finger on -1. Or you know what, let me start at the bottom. Let me put it on 2. Okay, for this input, how many outputs? One output, right? So far, so good. For that 2, one output. For this x, there's one x. For this x, how many y's? I got one y. So far, so good. So far, it's a function. Now for this x, uh-oh, I don't have just one y, I have two y's for that one. So this is not a function. Not a function. Okay? Now there's a little more to this. There's a graphical test for this, which we call the vertical line test. So part D asks us to graph this function. So -1, 1. Let me write these ordered pairs. -1, 1, -1, 3, 1, 2, 2, -2. All right, let's graph this thing. -1, 1. This is our x value or y value, right? So we go to the left one and then we go up 1. -1, 3. So left 1, up 3. -1, 1, -1, 3. 1, 2. So to the right 1 and up 2. 2, -2. To the right 2, down 2. 2, -2. Okay, so for this here's our graph, and we're going to test this now graphically. I know that we already know this is not a function, but to test it graphically, we call this the vertical line test, the VLT test. So if you have a graph, you can test it to see if it's a function. The vertical line test says for every x, there's one y. So let's test for an x value of 2. How many times did we hit? Once. So far, so good. So it can only hit once. How many times did we hit? Once. So far, so good. Now let's test it for this x value. So anywhere where this thing is defined, I'm like, uh-oh, I hit twice, not a function. It just failed the vertical line test. Okay, so that's a graphical test of this. The vertical line test is a graphical test. Let's do another one. 1, negative 2. What's our domain, first of all? Our domain would be 1, 2, 3, negative 2. That's our domain, right? What's our range? Negative 2, 1, 2, 2. Okay? If we were to do a mapping, let's say 1 goes to negative 2, 2 goes to 1, 3 goes to 2, negative 2 goes to 2. Let's test this. Is this a function? Okay, here we go. For this x, there's one y. So far, so good. For this x, there's one y. For this x, there's one y. For this x, there's one y. So yes, this is a function. Let's verify whether this is a function graphically. So you have 1, negative 2, 2, 1, 3, 2, and negative 2, 2. Let's test it. And you test it anywhere where it is defined. So I test it right here. Hit once. So far, so good. Test right here. Hit once. Good. Hit once. We're okay. And it hit once. We're okay. So yes, this is a function. It passes the vertical line test. Okay. All right. So again, for every x, there's one y. That's how you know if this is a function. All right. Let's look at a graph now of a function. We're going to graph this. We're going to ask you to graph it in this section by making a table of values. Okay. And then next time we'll look at and talk about some slope stuff again. So let's make it a table of values. I always like to start with these linear lines. Just start at 0, go a couple to the right, pick some x values, and then go a couple to the left of 0. Usually you'll get a feel for what these lines look like. And then we plug them in one by one. Negative 2x plus 3. Let's plug in x being 0 first of all. Plug in the 0. Negative 2 times 0 is 0. Plus 3 is 3, right? Now let's plug in the 1. Y equals negative 2 times 1 plus 3. Negative 2 plus 3 is 1. So you got the point 0, 3. 0, 3. I got the point 1, 1. Now I'm plugging in 2. Y equals negative 2 times the next value of 2. So negative 4 plus 3, or negative 1. So when my x is 2, my y is negative 1. 2 comma negative 1. Let's go to the left now, negative 1. Y equals 2 times negative 1 plus 3. Negative 2 plus 3 is 1. So negative 1. Oops, I did something wrong there, sorry. Negative 2 times negative 1 is positive 2 plus 3 is 5. Sorry about that. 5. Negative 1, 5. Negative 1, 5. And we go negative 2, 7, and so on. Okay, we get enough here and we just draw our line. You see that line there? So I just get a few points there, or a few x values, plug it in, take a look at it. Is this a function? I know we already called it a function, but does it pass the vertical line test? I say, well, how many times does it hit? Once. Anywhere I pick, it's only going to hit once, right? So it has to pass the vertical line test everywhere. So I say, yeah, sure. This line is definitely a function here. All right, let's talk about function notation. Function notation. So if you recall from your beginning algebra course, your f of x right here, this is just a nickname for y. Okay, this right here is just a nickname for y. And you say, well, why do they even bother to use it? Well, it's a nice shorthand notation that really comes in handy as you work with functions, and you'll find that as you progress through your college algebra and calculus courses. Function notation is just really nice to use, okay? And then this says evaluate the function when x is 2. So all you do is you plug this in and you find your y. Okay, so you're plugging that x value in and you're finding your y. Remember, f of x is y, okay? But the notation is you plug 2 in for x, okay? So this is saying, what this is saying is evaluate y when x is 2. Okay, that's what that whole thing is saying. But you can now easily just say find f of 2. And you kind of know what that means. Find f of 2. Well, let's see what f of 2 is. F of 2 is negative 6 plus 4, which is negative 2. F of 2 is negative 2. So what was our x value that we plugged in? We plugged in an x value of 2, right? So what point is this giving me? X value of 2. And what was my y? The whole y equals what? Negative 2. So my input was 2, my output was negative 2. So you can say f of 2 equals negative 2, or it's the same as the point 2, negative 2, if you will. Okay? 2, negative 2. Let's do it for this g of x function. So g of x is x squared minus 4x minus 1. Okay? And we want to find it for x being 2. So let's plug 2 in for x. 2 squares 4. Negative 4 minus 1, we got our negative 5, right? So g of 2 is negative 5. In other words, when x is 2, y, g of 2 ends up being negative 5. That's the point that you get, okay? So g of 2 equals negative 5. Make sure you guys bring any questions you got to class. We'll see you soon.